Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 asks, is BCl3 polar or nonpolar? So this is boron trichloride. Okay, so to find out whether or not a molecule is polar or nonpolar, we need to first draw out its Lewis structure. So when drawing out a Lewis structure, we need to calculate the total number of valence electrons for this molecule. So boron has 3 valence electrons and chlorine has 7. And since there are 3 chlorine atoms in this molecule, we multiply this by 3 to give us a total of 24 valence electrons. So now we can start by drawing out the skeletal structure for this compound. And our central atom will be the boron, since it is less electronegative than the chlorine. And now I can draw 3 single bonds to the chlorine atoms, like so, and draw in all of their lone pairs. So if I count out how many electrons I've drawn so far, each bond contains 2 bonding electrons, and each of the chlorines contains 6 non-bonding electrons. So in total, I have my 24 valence electrons already drawn. Now we can analyze our structure and see the type of structure by using a helpful VSEPR chart. I'm just going to look up a VSEPR table that'll tell us the type of molecular shape we have for this molecule. So if we look at our boron, boron has 0 lone pairs, and it also has 3 bonded atoms. So using the VSEPR theory table, this tells us that when we have 0 lone pairs and 3 bonded atoms, we have a trigonal planar molecular shape and electron geometry. And all of the bond angles are 120 degrees. Okay, so let's also recall that chlorine is much more electronegative than the boron, so each of these chlorine atoms will have dipole moments pointing in the direction of these chlorines. But if we look at our trigonal planar structure, you'll see that it is symmetrical. So I'm just going to write down here, we have a symmetrical structure. And all of these dipole moments cancel each other out. So we can also say that this molecule has a 0 net dipole moment. So because of this, BCl3 is a nonpolar molecule. Even though a boron-chlorine bond is polar. I'm just going to write up here, the boron-chlorine bond is a polar bond because of their electronegativity difference value. It's greater than 0.4 but less than 1.69. And the junior tutor said that boron trichloride is a nonpolar molecule. The 3 boron-chlorine bonds, even with dipole moments, are arranged in trigonal planar, which negates the individual dipole moments. Yep. So this solution is correct.